In this video, I will show you the question of worksheet 6. Okay, so question number 7, which is a little bit long. So first one, in the figure, G is the in-center of AB. Therefore, the in-center in the radius is inscribed to circle ABC's R. So what does this mean is the in-center is? That means is the G is the center of the circle and the circle is just inscribed in the triangle of ABC, just like this one. Okay, so we should have a circle inside it. Okay, and these three sides of triangles just touch. Okay, the circle, and therefore we can know that where's the R is should be the radius. So you still remember the relationship between the tangent and the radius is the radius. Okay, must be perpendicular to the tangent, so it should be right angle here. So R and R here. So therefore I need to write down some words to express for question A. So because G is the in-center of triangle ABC, so there are three tangents in it, which is be AB, AC, and BC are tangents to circle, and therefore the radius is perpendicular to the tangent. So in triangle AGB or BCG, BCG, because the question asking it in BCG. Okay, so BCG is this one. So R is the height of triangle BCG, and BC is the base. That means it's equal to A, so the area should be triangle BCG, which should be equal to 1/2 times A times R. So you finish part 1, and for part B, prove that R is in this way, and where S is equal to the perimeter of over 2. So it's quite similar to Heron's formula, right? So our direction is try to think about, consider the Heron's formula first, okay? So in similar way, we can get is AGB by A. Okay, we can get in similar way, we can get the area of triangle ACG and the area of triangle AGB, which should equal to, these two triangle first. The first one here, and the second one is here. These two triangle. Okay, should be like this. Okay, so one of it should be 1/2 BR, and another one is 1/2 CR. So the area of the large triangle, which should equal to 1/2 times AR plus BR plus 1/2 times CR. So which should be 1/2 times R. We can take out the common factor 1/2 and R. And we know that A plus B plus C over 2 is equal to S, as we know this one, right? So therefore, which is equal to RS. Okay, and on the other way, we know that because the area of triangle ABC by Heron's formula, which should equal to square root of S times S minus A minus B and S minus C. Okay, so that means these two are equal, right? So therefore Rs is equal to the square root of S times S minus A times S minus B times S minus C. So let's go back to our question is, prove that R is equal to something. So R is the subject, right? So in this time, we just change R to the subject. R is equal to square root over this one. So over S. And after some simplification, I can put it back to the square root of S by take S a square. So we have a cancellation. So it should be R equal to the square root of S minus A, S minus B, and S minus C over S. So which is equal to our question, right? Okay. So for part C, suppose the value of A, B, C is known. So find the area of A, B, C. So it's still easy to do it by Heron's formula. So I won't do it with you. So just do it by calculator, which is equal to 237 point something. So I can save it in A and give the answer in 3 significant figures is 238 cm squared. Okay, so we finished part B. Sorry, part C1 and part C2. Okay, the question of part C2 is, so find the radius of the inscribed circle. Once we know that for part B, we know the relationship between R and the three sides, so we can apply in it. So just substitute by B. Okay, so R is equal to this one, right? Okay, so I substitute is S is equal to 16 plus 30 plus 32 over 2, which equal to 39. And substitute the value of A and B and C is, so which should be like this. Okay, so you can get the answer is R is around 6 point something. And we can give the answer in 3 significant figures. Okay, this is the second C2 and the last part for C3. Okay, for C3, so the question is like this, is find the length of AG, so this length, right? So I will consider, first of all, okay, how can I find AG is, first of all, as AC and AB are tangent. So therefore, these two angles are the same. Okay, do you still remember these properties? And therefore, I will find the angle of CBA first. Okay, so once I finish the first part, I need to find angle CAB. And then for second part, I can find is GAB. Once I get these angles, I can find AG easily because I know the radius, right? So we start to present it now. So in triangle, okay, I try to copy that triangle first. In triangle ABC, so I can apply cosine formula. Okay. And you will get the angle is 29 degrees. Okay, so you get the triangle is, so circle inside it. So this angle is 29 degrees, right? And then you will get is, so angle CAG, which is equal to angle BAG. Okay, so angle BAG is equal to 14 degrees. So for the last step is, so you get this one is 14 degrees and the radius is 6.10. So AG will equal to 6.10 over sine angle BAG, okay? Because this is a right angle triangle. So this is R, this is A, this is G, and this is 14 degree. Okay, so you can get AG is 23.8 cm. So that's the end of the last question in worksheet 6.